Hi everyone, welcome back. We continue on this list and today we are going to learn about control matrix. Lastly we learned about the measurement matrix and we can directly switch to the code part. Actually, or maybe I should also warn the people who are directly watching this video. I will suggest them to back to the first Kalman Filter video, then back to here, because otherwise this can be confused. And I'm not trying to explain all the simulation code at a one time, because we are going by one by. Already we learned about here, so we will continue accordingly. This is not a long code, but it's good to understand Kalman filter. Also, as I said before, also this is already shared in my GitHub page. They can directly copy and try in their environment. And okay, in the last video I just checked this was not exist. I just put it, and just to keep this control matrix should be the transpose design of the measurement matrix. For example, this is 2 by 4 and this should be 4 by 2. Just keep in mind. And I just assign some default parameters 1 1 and 0 0. That is some square binary matrix. And okay, and other side I change nothing. We can without this maybe we can run the code and try to see the result. Okay, this is the normal one, and let's comment out again. Okay, just run this one. Okay, here, so the right is the one we always running and the left is the new one, and we see there is no change. Actually, even we continue, there is not gonna be a change. Why it's like that? Because there is an explanation here, surprisingly, because in OPENCV documentation we don't see many explanations. It says here not use if there is no control. So there is something we need to put. Even you define here as like this, it's not gonna work because there is something needed, which is control matrix, and this control input should be put into the prediction. Actually, we are defaultly working, there is no parameter inside this predict function, but it required to be able to use this control matrix. There should be a point input control inside this predict function. So let's define it. Maybe let's something use okay, anyway, maybe we can directly call cvmat and control input, okay, is equal to, I just wanna, maybe we can use something like this, okay, and float it is. So maybe this is should be 1 by 1. So we already defined our control input temporarily and put this inside the predict function. So now it's gonna consider my control matrix. So we will something different now, I hope. Let's run again. Okay, something wrong again. This should be 1 by 1, of course, because we are giving kind of point. What else? Oh, sorry, not 1 by 2 column, 1 row, sorry. Okay, now it's working. And let's see. Okay, now we see some difference. Then what we change and what actually is doing. Just for this, maybe ignore the red line because we already add a control input. Red line is not gonna work really fine. So we need to focus the green Kalman filter result, and we can compare with the right side. Okay, let's first of all start from the 0, and now we are considering our control matrix. But if we just change these things to 0, which is there is no effect, let's keep this also 100 and 100. So I want to explain these two rows at the beginning, and let's see the result. And this was the default, and see the result. You see there is no change actually in here. The everything looks similar to the right side. Why it's like that? Because actually this is only controlling these two rows, is controlling and affecting the acceleration. Since in our example there is no acceleration effect, we didn't give the acceleration dimension, so it's not, whatever you give here it's not gonna consider accordingly. So you can give anything, it's not gonna be included. So yeah, these two rows is controlling the acceleration. The first always x and the second always y. So x axis acceleration and the y axis acceleration, as we talked in the previous video how they are working also. Okay, so the other one is this two last row is affecting the speed. For example, if you put here 1, let's say, which is gonna be affecting the x dimension velocity, here controlling the x and here controlling the y. So here is gonna control the x-axis velocity. Maybe, for example, this is the default one, and let's run. So we only change x. There is not gonna be effect in the y direction. So you see, there's looks like there is an effect, but actually we just change the velocity a little bit, so it's gonna give an offset, looks like. So it's gonna be appear like this. So but also if you give minus, so it's gonna offset according to the left side. Yeah, it's affecting the left side. Also this is gonna include the y-axis. If you put this one, I think there's not gonna be a change. It will looks like to the similar to this one, because what we did currently, these are balancing each other, so there's no effect because our speed is 5 to 5. But if you make this 15, so y-axis is little, so it's considering the y-axis velocity in the x-axis velocity, so it's taking consideration of the y velocity into the x velocity. Now we effect will be in the right side. There is gonna be offset in the right side we are expecting. And let's see. Okay, since we change the y direction speed, it's little, yeah, there is many volatilization in here. Maybe if we make 10, maybe we hopefully we see more better result. Okay, since in the y direction is moving much, we cannot understand clearly. And but anyway, but maybe just to be sure, make it here 0 and make it here 5. Now expected behavior, I think we should see, yeah, now it's only considering the y-axis velocity in the case of the x velocity, so we see the same result as we tried at the beginning. And yeah, similarly in the y direction also you can try. If you have an accelerated dimension in here also, you can play with these two rows and you can see the effect. They are gonna these controls input externally is given, as you see in here in the prediction part. So these are affecting the result, acceleration and the velocity they are affecting. And yeah, for this video simply I wanted to talk about this control matrix, and see you in the next videos.